Okay, this is Dr. Williamson doing another rate of reaction problem. And so in this one, I'm using Microsoft Excel because it had a nice little graphing. And here it says the compound AX2, which is supposed to be here. Let's do this. Supposed to be here. AX2. Okay, that's what it's supposed to be. Reacts according to this chemical reaction right here. In one experiment, the concentration of AX2 is measured at various times. So here it is at various times, its concentration was measured to be this. And first part is find the average rate for the whole experiment. Second, determine the initial rate of the reaction. And you'll notice here, I'm an engineer, I cannot spell, but that is spelled correctly within significant figures, right? Plus or minus one letter. So to find the average rate for the whole experiment, I can just go the rate of the reaction will be equal to minus delta AX2 over delta time over the whole experiment. So the final concentration will be 0.0188 molarity minus 0.06 molarity. And I'm not going to worry about sig figs. I should, but I'm not going to in this problem because I'm trying to write with my dang mouse and it's really hard and I'm just being a little bit lazy. Okay. And then over the entire time, I'm going to have 20 seconds. So it's going to be T final. So it's 20 seconds minus the initial seconds, which is in this case 0 seconds, parentheses. So I get my calculator out. Don't know where I placed my calculator. Here it is. So I'm going to go 0.0188 minus 0.06. That's going to give me negative 0.0412 molarity divided by 20 seconds, because 20 minus 0 is 20. Notice I got a negative, but I have another negative. So when I finish all this, divided by 20, I'm going to get, where to go? Okay. I'm going to get positive. Wish the thing would stop doing that. Positive 0.0206 molarity per second for the average rate over the entire reaction period. So from here to here. Okay, that's how you do that. Now I'm going to erase this because I need the space. All right. That's how you do the first part. Okay, now it says I need the initial rate of reaction. That means I need a tangent line at t equals 0. That means I need to draw, here I'm going to draw kind of a really poor, okay, that's a very poor best fit line. right? Because again, I'm drawn with my mouse, but you guys get the idea. And I need to extend this line or extrapolate backwards. So I'm going to extrapolate backwards and kind of continue what it would probably look like going backwards. And then now I need to draw a tangent line to that. Tangent line where it touches right at here, t equals 0. And I didn't do it very well, but you guys get the idea. Then I'm going to take 2 points off of this tangent line. Let me kind of continue extending this. Right? Let me continue extending this. Stop blinking. Right? I don't know why it's blinking like that. I hate that. Right? So I'm done. Stop blinking. All right. So now what I need to do is take 2 points off of that tangent line. So I'll take a point here. This point right there. Blinking again on me. This is a new, I'm, using this feature. Come on. Oh, here, let's do this. All right. So I'm going to take a point right here. That looks like that's about 0.052 and 2 seconds. So I'm going to have here R equals minus 0.052, and that's at about 2 seconds. This is molarity. And then if I extended it down to right about here, that point there is 0.05, and that looks like it's about 3 seconds. 0.05 molarity and 3 seconds. Right? It's sloppy because, it's doing this blinking around on me and I'm writing with my mouse. But the point is you learn how to do it, right? The technique. So when I go ahead and do this, I'm going to go 0.05 minus 0.052. That's my estimated values. That's going to give me negative 0.002 molarity. 3 seconds minus 2 seconds will be 1 second. We're not worried about sig figs. You should be, but I'm not worried about sig figs in this demonstration problem. Now I got a minus sign and another minus sign because reaction rate is never negative. And so when I'm done here, I'm going to have the reaction rate as positive 0.002 molarity per second, which is the same thing as 0.002 moles per liter per second. Which one do you use? Both. I expect you to be fluent with both. Okay. So here I took this chemical reaction, said find the average rate. So all I did was just take these numbers. This was the initial. This was the final. And I used the numbers from the data itself. Right? And I found the average reaction rate. To get the initial reaction rate, I have to draw a tangent line at t equals 0. So what I did first was kind of extrapolate the best fit line backwards. Then I drew a tangent line to that best fit line. Then I took data points off the tangent line, not off the curve. Take the points off the tangent line, and then those are the points I put in here. If you don't take the points off the tangent line, then you are wrong. Okay, and you'll lose points. Okay. Anyway, I hope that helps, and I'll put up some more problems later. Okay, then.